Keeping up with security issues across thousands of web assets without the right approach to web application security is a daunting task. Get ahead with web vulnerability scanning automation from NetSparker, a leader in dynamic and interactive application security testing known for its ease of use and accurate results. Detect a wide range of vulnerabilities in all legacy and modern web applications, address security bugs at scale by automating the confirmation process, automatically prioritize vulnerabilities, and assign actionable tickets to the right developers in their native workflows for rapid remediation. For more information on how to scale application security with ease, visit securityweekly.com/NetSparker. Welcome back, everyone, to Paul's Security Weekly. A couple of quick announcements. The Cyber Risk Alliance, in partnership with InfraGard, has launched the Critical Infrastructure Resilience Benchmark Study. Measure your readiness for ransomware by completing the survey and getting your score by visiting securityweekly.com/CIRB. Security Weekly Unlocked will be held in person this December 5th through the 8th at the Hilton Lake Buena Vista. We're excited to announce our first round of speakers that includes David Kennedy, Alyssa Miller, O'Shea Bowens, Maria Chinavada, Patrick Coble, Chris Eng, Eric Escobar, Kevin Johnson, and Justin Kohler. Visit securityweekly.com/unlock to register and check out the lineup. Joining me for this interview, Mr. Lee Neely is here with us. Lee, welcome.
Good to be here. I'm looking forward to hearing about Wheel's research.
Yes, always interested in the research coming from Wheel and the Qualys Research Team. Wheel is, of course, part of a small but very impactful research team at Qualys, who recently discovered, among other open source vulnerabilities, a vulnerability they dubbed Sequoia, a local privilege escalation vulnerability in Linux's file system layer. It's a kernel level vulnerability, giving it a CVE 2021-33909. Here to talk about it today is none other than Wheel himself. Wheel, welcome back to the show.
Hi, Paul. Hi, Lee. Hope you're doing well.
Yeah, doing great. Really interested in this vulnerability. There's a lot of different and interesting aspects to this vulnerability. I guess we'll all start with what made you want to go through the punishment of looking at kernel level code in Linux?
Well, it was a bit of luck. Actually, we were just reading the kernel code that generates some of the files in the proc file system, the pseudo files in the proc file system. Then we spotted a possible issue in the growth of a variable. We were wondering if this variable could reach a maximum value, what kind of value it could be, and so on. And we wondered if we could make this variable so large it will reach a value larger than the so-called maximum path length, because in some way it was related to the length of a path file on the file system. And well, we found a function with a wrong integer type that was using this variable, and that was it.
Yeah, it's kind of interesting how you could describe this as a vulnerability that we can categorize, that's in like common weaknesses and enumeration, and that is a type conversion vulnerability. Mm-hmm. But also, I believe it was a programming assumption that the max length of a directory structure should be a certain value. Is that correct?
Yeah. Actually, as you just said, there is a bug which is very, very well documented: the conversion of a very large unsigned integer to a smaller signed integer, which can end up with a catastrophic behavior. And the fact that most of the time the programmers tend to forget that the maximum length of a path, the full path of a directory or a file, can be way larger than it used to be a few years ago. The maximum length was like 4 kilobytes a few years ago, and then the limit changed in Linux, but most of the software didn't make some of them make the verification, but some of the programmers didn't make the verification that their code were actually compliant with the new limit. So yeah, it was interesting.
That's interesting. Sorry, Lee, do you have a question?
I was just going to say, so wait, they changed it in one place, but not everywhere else that was related to it. So therefore, you wound up with the vulnerability. That almost sounds like sloppy coding, but I don't want to put too fine a point on it.
Well, it's difficult actually because it's not that easy. Actually, the main problem with the Sequoia vulnerability is not really the fact that you can have a huge path, because it's accepted, all right? But if you add this behavior with the fact that you have the type conversion issue, then the combination of the two, not the two bugs, because you have one bug and a programming assumption, make this exploitable. But when we wrote the vulnerabilities for the exploit for Sequoia, we end up crashing the system because another component of the system, which is system D, made a kind of assumption that the path of the file can be very big. And the fact that we managed to make 1 gigabyte long path completely crashed the system, because of obviously system D is the PID number one. So if it crashes the whole box. So you can have a weird behavior, you can have simply bugs, and sometimes you can have a vulnerability.
With the type conversion, shouldn't that trigger a page fault? Right, you had to kind of find your way out of not triggering a page fault, correct?
Well, actually, the type conversion is not related to a page fault. The page fault is more related to the fact that systemd crashed in the other advisory we wrote, and in one exploitation we made of the Sequoia vulnerability, because you could have many kinds of exploitation, many kinds of exploits, and in one of the exploits we wrote, the page fault used to appear at a certain time, but we managed to bypass this restriction in the exploit.
You basically had to find a different area of memory that wouldn't trigger the page fault?
Yeah, actually, in the kernel, you can have I won't say only two, but you mainly use two kinds of allocation in the kernel, which are kmalloc and vmalloc.
Mm-hmm.
And vmalloc is allocates memory in a certain area in the address space, and this allocated memory area is protected by guard pages, which means that you can't overflow in one way or another. Otherwise, it will raise a page fault, or it will crash the process, basically. But in the exploitation, we didn't have an overflow which writes every page from the where the buffer is at the beginning to the destination where we want to write memory. Mm-hmm. We didn't have to write on every byte until this area. We managed to jump directly into this area, so we avoided the guard pages. And
guac what did you call those? Guac pages?
Guard page.
Is that just areas of protected memory? That's protected by the kernel, right?
Yeah.
I got you. So it wasn't necessarily straightforward getting the overflow.
No. It was very difficult to exploit because you have this kind of limitation, and the fact that you find the bug, you think, it might be exploitable. You start writing the exploit and writing the advisories, and the kernel community is very active, and they write a lot of code every day. So the code base changes every day.
Yeah.
And one day your exploit is functional, and the other day it doesn't work at all. So you have to turn the problem around and find a more robust way to exploit the vulnerabilities so that minor change here and there doesn't affect the exploitation. So it was no small feat to make a real exploit, actually.
Yeah, I think it's interesting in Linux that I think the approach largely for Linux and Unix systems is to give the user more control. And in that control, I should be able to, I think in some programmer's mind, right, be able to create nested directories that could equal a gigabyte in length. However, that's not really practical. I mean, maybe. I mean, did you consider, like, should the user land stop the user from creating directories at a certain size?
Yeah, it's not easy because it's always a matter of trade-off. If you write hard limits in the kernel code or in the libc or in the whatever, you will always end up finding users, specific use cases where the limits are not good.
Yeah.
So the mindset is more like we don't make any limit at all, or a very huge limit like the maximum value of size underscore t types, which is basically 2 power 64 minus 1.
Mm-hmm.
But then you can have very weird behavior, like huge paths, which are completely useless. But as we don't know how the future will be, yes, we let this door open. But for the attackers, it's a good opportunity to trigger weird behavior, maybe vulnerabilities and exploitation.
So did you have to fix the systemd bug in order to be able to write a reliable exploit?
No. We contacted the systemd developers. But we didn't fix the bug. We found another way to exploit the vulnerability.
I gotcha.
So wait, you came up with 2 exploits then?
Actually, we had we had an exploit for Sequoia in the first time, but due to the changes in the Linux kernel, we wrote another one, a more robust one, and not depending on the same constraints. So, and this one was quite difficult to write because it involves 1024 thread synchronization at a very fine grain level. So it wasn't easy at all. But yes, we wrote it, and but you might. I'm pretty sure people familiar with the kernel can find a lot of other ways to exploit this vulnerability. Because we don't know the kernel very well. It's the first time we audited. We didn't audit the kernel basically, but it's the first time we were writing an exploit for a kernel bug.
Yeah, that's really interesting. And when you were telling me that, Will, I was like, so that means you had to interface with the Linux kernel development team. And I'm assuming a bug of this nature, it might even cross the desk of Linus Torvalds himself. And you have some experiences there, which I think are positive. We agree.
Yeah, sure. We exchanged a few emails with Linus, and it was very, very positive, actually.
Yeah, which now many people wouldn't expect that to be positive. As we know, Linus tends to be very outspoken, especially about bugs in the kernel, right?
And especially if it's a private conversation.
Yeah.
You might think that in the public, people are well educated and and cool, and in the private they can change. But
right.
It was really nice, really interesting, and he was really open-minded about how we can synchronize the Qualys and the Linux kernel to make sure the embargo fits everyone and so on. So it was nice.
And so tell our audience about the embargo kind of aspect of, I mean, I think you run into this with all open source vulnerability disclosure programs or exercises, right? There has to be an embargo program, if you could elaborate on that.
Actually, there has not to be an embargo, but if you want to make a responsible disclosure, you often have to set up an embargo period. which an embargo time, which is basically you contact the author of the project where you found a vulnerability, a bug, or what a project you managed to exploit, and you discuss with the authors, try to find a way to fix the issues eventually, and you ask him how much time he will need to find to write the bug fixes, and during this time, between the moment you contacted the author of the softwares and the moment you release the vulnerability in public, people don't have to know what's happening. Because otherwise, if the information is leaking, well, the bug is not fixed, but the vulnerability is public. So not well-intentioned people could try to exploit the bug and take control of systems. So we have to be very strict about this period. And once the embargo period is over, then the project releases the patches. Or the new version of the softwares or whatever, and we publish our advisory.
Right, because when you contact the project, you give them the full details of the vulnerability and ask them, basically, you can't enforce it, right? But you ask them, like, hey, just don't push this patch out because we need to do some planning, because if the patch goes out, people will know how to exploit it, and then it's public, and then your disclosure goes out the window.
Yeah, sure. Sure. And as a security company, you have to make sure everything is doing by the book. So
yeah, and especially with the Linux kernel too, because all the distributions have to get ready to apply a kernel update and such.
Well, you have some projects also where it's very difficult to synchronize everybody, because a few years ago, I think it was in 2017 when we published the Stack Clash vulnerability. And the Stack Clash advisory, the vulnerability lied across like 6 or 7 operating systems, by basically all the DBSD, Solaris, Linux. So we had to make sure the embargo was respected by everyone, and it wasn't easy because everyone has his own agenda, his own milestones, and it's not the funniest part of being a security researcher.
Yeah, certainly. Yeah, because you got to deal with people. Lee.
So I'm looking at the disclosure timeline on your blog. Is that about normal, or is that quick? I mean, it seems fairly short given the scope of the places that have to make kernel and other changes.
Well, when you work with the kernel, it's really fast in general, because they just say give us the details and we will patch it as soon as possible. Tell us when you want to release the advisory, and we will align our patches with this advisory. So as they are very proactive and reactive, they might even fix a bug in a couple of hours. But then you still have to be sure that a minimum period, a maximum period, and of embargo is respected by everyone, because there is not only the kernel affected by this vulnerability. We had the system D as well. So you have to find the balance to make sure everyone is happy with the embargo.
Yeah, that coordination's hard.
I was wondering if you got involved in verifying the patches fixed the vulnerability, or did you leave that to others?
In this very case, I didn't review the patches. It often depends on the project. For instance, with the Sudo vulnerability, the author asked us if we were happy with the changes. In this case, it was pretty straightforward. So, and moreover, they are really experienced developers in the kernel, and they used to handle this kind of bugs and fixes. So, in this very case, it wasn't necessary for us to read the patches.
Did you get the sense, Wheel, that the Linux kernel team was appreciative of your efforts?
I hope so, but I can't tell.
Yeah, it's kind of hard. I'd imagine that they're going, "Wow, that's some pretty creative, method," and glad that you reported it responsibly to them.
Yeah, but for a long time, the Linux kernel point of view was a vulnerability, a security bug is just another bug.
Right.
So they don't really care about the exploitation or the kind of vulnerability. If it's a bug, they have to fix it, and that's it. So I think that it's not very interesting for them to know how we can manage to exploit this bug to get the root or whatever. It's a bug. They have to fix it as soon as possible, and let's move on.
Mm. Yeah, it's really interesting. Also, I find it interesting how much the code base has grown for the Linux kernel. Right, it started out with basically tens of thousands of lines of code, and now I think we're beyond 10 million lines of code for the kernel. Is that true?
Oh, I think we are way over 10 millions.
Wow.
But most of the code, if I remember correctly, is part of the Linux kernel drivers. So it's not necessarily the Linux kernel team which is responsible for writing this code. It's more like the author of the hardware, or people who wants to make a very weird component work on their system. So yes, but it's a huge code base, absolutely gigantic.
Yeah, and that's interesting how it's distributed, right? Because the user land binaries each have their own. Many of them have their own maintainers. The Linux kernel has their own maintainers, and then there's the driver support in the Linux kernel. And those are all disparate teams, right?
Yeah, actually, I don't know exactly how the driver, the Linux kernel driver works. So I don't know. I think there are some Linux kernel developers who are responsible for integrating the drivers from third parties. So they have to know this kind of code very well. But yeah, it's a weird place, the kernel.
Yeah, it's a very unique skill set from a kernel developer perspective, right? I mean, this is not your average everyday C code, for example.
No, all the allocation routines are different. You have to be sure that the slightest modification doesn't end up with catastrophic consequences, because a bug in the kernel is not a bug in the average mailer. So you have to be very rigorous and patient and meticulous. But I'm not experienced at all in kernel development, so I don't want to say anything blatantly wrong.
Right, and I guess my point is not many people are, right? And that's why when you sent the bug and they're like, okay, we're going to fix this, because there's only a subset of people in the world that can understand enough to put in a fix and make sure it doesn't break anything else. Yeah,
sure. But I think there are a lot of people working in the Linux kernel. So there's always someone who is up to answer your question and fix the bugs. But they have to make sure there is always someone.
Well, my question is, as big as the kernel is, or as big as the source is for Linux, how do you figure out where to focus and look and see if there's any issues? I mean, it seems like it'd be just this huge set of places you could look, and you could spend all day scratching your head trying to decide.
Yeah, sure. Actually, we were wondering how the kernel manages very specific files on the system. In the Linux kernel, you have the proc file system, which is a pseudo file system. And this pseudo file system exposes values in the kernels, available in the kernels. And this pseudo file system exposes these values to the user. So we were wondering how the kernel manages to write these values and in the proc file system, and because we were thinking of weird behaviors, I won't I won't go into too much in the details, but we read the code about the sequence files, which are responsible for displaying these specific values. And this is where we found an interesting behavior, the exponential growth of a variable. And when we dug up a little bit, we found the integer type conversions. So it wasn't random. We didn't randomly open a file in the kernel and found this bug. We had the kind of curiosity for a specific behavior.
Right. Yeah. The user interface with the kernel as being an avenue to potential vulnerability.
Yeah, sure. Because if you can trigger a bug in the kernel by opening a file in a sudo file system, in a proc file and a procfs, since a lot of the files available in the procfs are readable by the average user, then the average user can trigger the bug and maybe exploit it to gain root privileges. And this is what happened actually. We used the file, the mount info file in the sudo file system, which simply lists the directories where the file systems are mounted. And we then thought, what happened if the directory is very, very big, is huge? Then we found that we have the bug and we can trigger the bug from a user point of view.
And did the architecture matter for this particular bug? Like, how widespread was this? Because the kernel supports multiple different architectures, obviously, right?
I don't know. Actually, we only tried on some 64-bit systems on Intel architecture, but we didn't try on the other ones actually. So I don't know.
That's for the kernel developers to decide.
Yeah. Yeah.
Which also makes kernel development interesting and difficult too. Linux runs on so many different architectures.
Yeah, sure. But I'm pretty sure the attackers can read the code and try on the
leave it to them. If they really want an ARM exploit for this, right? They can go develop an ARM exploit because your payloads are going to have to be different.
Yeah.
One of my questions was, I mean, you make this sound fun, although a lot of hard work. It still sounds kind of fun. Is that an accurate impression? And the second part of my question is how hard is it for you to find people with the skill sets like you have to actually do this kind of research and exploit development? Is it challenging to find peers here?
Well, for the first part of the question, it's fun when you find the bugs because you kind of have an epiphany, you know. You read the bug and then you're like, gotcha, the kernel. But then you have to exploit it. It's not fun at all. Well, on the second part of the question, I don't really know. You know, I'm not a security guy. In the first place, I'm a low-level developer, so I don't have much connection. I don't have much connections in the security world, and but I guess there are a lot of people, a lot of very, very talented people out there who can find this find or understand or appreciate this kind of bugs and exploitation. But yes, it's still it was a small community back in the days, but nowadays there are more people because the security is an important field in IT. So you have a lot of young people playing capture the flag contest. So I think there are a lot of people very, very, very talented and very good out there.
And implementing on the fix, right? Implementing the fix for this is pretty straightforward for Linux users, right? I mean, they apply the patch and probably with very little impact, these patches could be applied.
Yeah, they just have to update their system. The Linux kernel developers, the other kernel developers, if they don't have a new kernel available by their distro, they can simply apply the patch, which is basically a one-liner.
Mm-hmm.
I think I didn't read the patch, so I can't say 100% it's a one-liner, but I think just changes the type is enough.
Gotcha.
But yeah, using your distribution, update your system, patch the system, and that should be it.
Lee, do you have a question?
Well, I was actually thinking, do you run into people who want to join you in doing this kind of work, and how do you get people started? I mean,
sorry, I didn't hear the end of the question.
Let me try again. What I was thinking about is, what you're doing is hard and kind of cool, and I was wondering if you run into people who say, "I want to do that too, Wheel. How do I get started?"
I would say just read the code of the tools you are using. Read the write-ups, because a lot of people write how they exploit vulnerabilities, like Qualys with their advisories, because you can have new ideas when you read the work of other people, and just be curious. Try to come with new ideas. Be curious. Read the code. Ask advices from other people, because there are a lot of people who are in the security field for a long time and are very, I think eager to help the newcomers, and try a capture the flag contest, the online challenges, to know what part of security you like, because at the very, very beginning you often say, yeah, I like security, but security is a very, very wide area, and but the biggest advice, if it's an advice, it's to be curious and don't assume anything. Just question everything.
Wheel, how did it feel when you found out that you and the Qualys Research Team collectively had won not one, but 2 Pony Awards?
It was nice. I won't lie, it was nice. But we were nominated a few years ago, and the last year as well, for several categories, if I remember correctly. And it's cool because it's a kind of achievement. Well, when the community says, "Well, Qualys, we are very happy with what you've done," here an award.
Yeah, it's validation.
Yeah. But on a daily basis, it doesn't change anything for
right. How did you feel about the underhyped research? Do you also believe that the 21 nails, the exit mail server vulnerabilities were underhyped?
I wouldn't say that, because I was on Security Weekly to talk about 21 nails. Maybe some people in the juries found that we didn't have enough credit for this advisory, because 21 nails was a huge amount of work. When you arrive with 21 vulnerabilities on the table, it's always impressive, I think. But actually, since I don't remind exactly who were the other contenders, I can't say if it's okay to win this award.
Right.
Maybe the other contenders were very good and better than us. I don't know.
Yeah, I think it's interesting, because obviously we helped you promote that. I thought Qualys collectively, we did a great job of promoting that. I thought it got a lot of press as well. I mean, I read about it in, the mainstream source, air quotes mainstream that we follow, and there was a lot of awareness around it. I also think to your credit as well, calling it underhype means you didn't overinflate the importance of a particular vulnerability either.
Yeah, maybe. I don't know exactly on what criteria they vote. So,
Lee, you had a question for Wheel.
So, Will, you do an excellent job of explaining this and talking to us. And you characterize yourself as a low-level developer. And I'm just thinking the skills you have to explain this and talk to us, did those come naturally, or do you have to work hard?
I will take this as a compliment because I don't find me very good to explain this kind of bug. But I don't know. I'm not very comfortable, with public speaking and podcast and talks. So I'm just maybe, I don't know. I'm trying to understand what we're doing in the team, so that I can explain it to non-very very specific and very very technical people, and that's pretty much it.
Yeah, no, you do a great job. It was definitely a compliment because explaining some of this stuff it can be tricky, right? And allowing people to understand it that maybe are Linux users but on varying different levels, or not Linux users at all, that's tricky.
Yeah. It's not easy to go outside the very technical details and explain it to people. I don't know.
Yeah. But, I think if you take away from this that, one, it's a kernel level vulnerability. So if you're running pretty much any flavor of Linux, right, this is probably coming up on your radar. The patch seemed, in your explanation of it, like pretty straightforward. So like pretty safe to just go apply this patch. And even if that's, the takeaway from this, I think that's important for, a lot of people, organizations, I should say, have Linux, but it's not really in the forefront, right? It's running on their cloud infrastructure, and they're not active Linux administrators. Some are like, wait, do we have Linux? Oh yeah, we've got AWS, so we have Linux. So I think it's important for those people to understand that this is an important patch to apply. And in our assessment, at least my assessment, is relatively little impact in applying the patch.
Yeah, it's very specific. It's really in one function, so the code is not widely modified to fix the bug. You're right. Many people run Linux without knowing it. So it's important to patch the system as soon as possible. But I don't know exactly. It's difficult to know exactly what systems were vulnerable, because the bug was introduced in 2014, but writing a bug, committing a bug, and being able then to exploit the bug is two different things, because as I said prior in the podcast, the Linux kernel changes a lot. So you might have a bug which is completely unexploitable.
Right.
So maybe the bug was introduced in 2004 and was exploitable since 2017. And maybe it will be there are still bugs out there. Surely there are bugs out there which are completely unexploitable. So
yeah, and it's always interesting for me to think about who may have found this before you, right? In this particular case, does it leave a trace on the system if you're not cleaning up after yourself of that like really big long directory structure? So if someone else found this in the past 10 years, we might have known about it.
Yeah, maybe, but I guess people were able to write this kind of exploit to exploit the vulnerability are also able to completely clean up the mess just after they're on the system. So especially since you have to create thousands, hundreds of thousands of directory, it will be the administrator or some security routines will find
right. It's an anomaly that you don't want to clean up.
This anomaly. So Yeah, I don't know. Maybe people were exploiting it. I'm not sure at all. But it was quite difficult to exploit, and it was a very very tiny bug. I think there are more interesting targets for the attackers.
Right. Yeah. It's interesting. I think, and I agree. Like what you're saying is, there's easier bugs and/or vulnerabilities or exposures that accomplish the same goal without going through the trouble of developing this more advanced exploit.
Yeah, sure.
Yeah. So, like, make sure you change your passwords and have good authentication and things like that first, right?
Yeah. Don't run old binaries, old servers. Be up to date, and that should be okay.
Well, the nice thing about this fix is it's apply the patch. There's not a step 2, do these 5 manual steps kind of thing, which is a lot harder sell to get people to apply, and harder to automate as well. I mean, I know you can automate some of that stuff. It's just when it's just go run your regular patch cycle, it's much easier to have people successfully do that and agree. The interesting thing about this exploit is because of that long path, I'm wondering what layered products didn't set themselves up to handle that kind of a long path string, beyond the Linux kernel, which is out of scope of where you're looking. I'm just thinking, I wonder what else will be upset with it.
Oh, well, I read a little bit of source code for some tools, and found that a lot of them don't manage very big paths in a smooth way. But it's not always a security issue. Sometimes it's just a crash.
Right.
But a simple crash might end up in a denial of service, depending on the server or the software. So, yeah.
Yeah, and it's interesting, when we look at updating the Linux kernel, that can be more difficult on IoT-based devices, especially ones that are past their support. But in this case, I'm not really worried about someone exploiting this on an IoT device because they may not even have enough disk space to create the directory structure, right?
Yeah, sure. And on most IoTs, I don't even... I'm not very... I don't know IoTs very, very well, but I don't know if you have a user access on IoTs very often, because these vulnerabilities, this exploitation gives you a root shell, for instance, if you already have an account of the system.
Right. Yeah, it requires shell access.
Yep.
Will, anything else on Sequoia or the systemd vulnerabilities that you want to inform our audience about?
No, it's okay.
I think we covered
I find
it well.
Sequoia a good name, actually.
Yeah, I do too. I thought it was very, very nicely named. And I can always ask you what you're working on now and what's coming up next. And I know you're not going to tell me, and that's totally fine.
Exactly.
But I think it's great that you're looking at these types of issues and reporting them responsibly. Of course, we talked about this on the last one as well. That there's so much code that benefits from this level of analysis, and finding the more popular ones in things like exim and sudo and the Linux kernel, I think is great, and hopefully encourages others to look at source code and vulnerabilities in this way and disclose them responsibly.
Yeah, it would be cool, and then encourage people to write good code as well.
Yes, yeah, I think. Well, and I think your advice for people that are looking to get into this, right? I liked it that you said start with like a program that you're running, so you know what this program does. You're using it. Go look at its source code, then go back and look at some of the examples, because a lot of these types of bugs haven't really changed in the past 30 years, right? It's just kind of a different way of thinking about it. I thought that was great.
Yeah, sure. The language is very old and doesn't evolve quick enough. So yeah, the bugs are the same.
Yeah,
always.
I find it interesting to look at the common weakness enumeration, and you find, I think I did look at the type conversion one, and then it'll give you some references, largely which I can understand, but apply those references to actual running software is a totally different story. But they also tell you like this type of bug came up in these CVEs, and oftentimes those CVEs are really old and also really new. So like these bugs don't really change.
Yeah. It's a really tiny bug. It might look innocuous and not dangerous at all, but combined with other weird behavior, other small bugs, well, when you put everything together, you can have this kind of vulnerability. So you have to take care of everything.
Fantastic. Will, thank you so much for appearing on Paul Security Weekly.
Thank you, Paul. Thank you, Lee.